Hello everyone, my name is Sajad Salmanipour and I am glad to briefly explain recent highlights of my research on remote actuation of small magnetic mechanisms. In this work, we focus on quasi-static homogeneous magnetic actuation. This is a valid assumption specifically in medical applications where the magnetic sources must be located outside of the body. In previous works, researchers have succeeded in developing systems up to 6 DOFs using these fields. Here we propose an 8 DOF magnetic mechanism, which can be potentially useful in applications such as multi-agent or flexible mechanisms where more degrees of freedoms are needed to be controlled. In a quasi-static homogeneous magnetic field, actuation power is transmitted to remote magnetic devices by the application of magnetic torque and magnetic force. The magnetic field denoted by B induces a rigid body torque while the gradient of the field generates a force. In this work, we investigate the magnetic field and its gradients to develop a system utilizing all of the independent components of a magnetic field. Maximum number of independent outputs cannot be greater than number of inputs, which is 8. To validate the possibility of this maximum of 8, we designed a simple system with 7 remote magnetic agents. Each one of them is able to travel along 1 or 2 axes, possessing 8 DOFs in total, denoted by D1 to D8, where each one is actuated by a force and a torque element. Our field generation prototype is an optimized coil configuration capable of independently generating 3 field elements and 5 gradient elements. Our 8 DOF magnetic mechanism is built using 7 pieces of nitinol wire attached to 7 cubic permanent magnets, and 1 stationary camera provides XY position measurements. To verify the capability of the system in individually actuating each degree of freedom, 8 open-loop experiments were conducted. The duration of each is 5 seconds and are designed to displace each degree of freedom from 0 to 600 micrometer in a linear ramp profile. As you see, D5 is now actuated, follows the desired trajectory where the rest of 7 outputs remain close to their initial positions. D7 and D8 are the last degrees of freedoms. D7 is moving now, and the last one, which is D8. In this work, we developed an 8 DOF magnetic mechanism as a proof of concept to demonstrate maximum capabilities of magnetic fields. These results serve as a general framework which will potentially allow for developing future magnetic systems with maximum dexterity. Thank you, and looking forward to see you in our interactive session.